Okay, hi guys. My name is Edmund. I'll be teaching you guys Add Math. So welcome to Teacher May's Add Math class. As a reminder, you need to switch on your camera at all times. All right, remember that. And also show your face, okay? Don't show your ceiling. I want to see your face, so that's more effective this class. And also you're helping me to not like feel like I'm talking to a wall. All right. Okay, thanks. Okay, so we will start with chapter 1, which is functions. So one by one. Oh yeah, if there's anything you can chat with me lah. Okay, you just type in the text and then I'll respond. All right. So chapter 1 by 1 is mappings. What is mappings? Okay. So for instance lah. Okay, we have if you have a graph. If you have a graph which is, let's say, y equals to x plus 1. All right. So if x equals to 5, we can say that y equals to 6, right? Now let's look at another one. Y equals to x squared. So when x equals to 5, your y equals to 25, right? But if x equals -5, your y is also equals to 25. So there's another one. Okay, let's look at another one. Y equals to square root x plus minus. So when x equals to 4, your y equals to -2 and +2, right? Okay, not. All right. So this one, you notice that your x, I can get two different values of x that gives me the same value of y. Can we get another value of x for this one to give us y is 6? You cannot, right? So there's only one, right? So this is what we call a one-to-one function. And then this is many-to-one. This is one to many. So these are the three that we will talk about in this 1.1 mappings. Okay. So this one, as you can guess it, probably you can guess it that this is x and this is y. And this is x, this is y, this is x, this is y. So you have only one x that can give you one particular y. You cannot have another x that gives you the same exact y. So that's why there's only 1 to 1 lah. 1x to 1y. So here many to 1 means you can have more than one x values that gives you the same y, which is this. Then for this one to many, one value of x can give me many values of y. All right, they don't care, is it 2 or more, it's considered as many. As long as it's more than one, it's many. Right? So in the notes, I hope you guys have received it. Okay, so this one. So this is the graph for 1 to 1 for fx x plus 1 lah. Okay, fx is a notation for function, we will learn later. So this is like for now you treat it as y, okay? So y is x plus 1. So this is the graph, it's a straight line. So there's only one x that can give you that particular y. So the next one is many to 1. All right. You can either call it 1 to 1 or 1 1 lah, okay? It's a different way of saying. But I'm used to many, to add the 2 there, I'm used to that. So okay, many to 1. So you see on the graph, you can see that two different x can give you the same value of y. So this is 1 to many. All right. So this is the graph. Yeah. Okay. So as you can see, one value of x can give me two different values of y. This one, two different values of x give me one y. This one x, one y only. So in x, we can try some questions. Okay. So today is just the first class, so I won't expect you all to know the shape of all the graphs lah. So what we can do is we can use this website. I don't know if you heard of this one called Desmos. This website. Yeah. This is a very useful website. You can use it to get the shape of graphs, and it's free. You don't need to pay. So I will use this website to help us with 1.1 lah, so that we don't need to, know the shape of the graph. You don't need to memorize it. Okay, so the first one is 2x plus 3, right? Okay, let me see. So you also can try it by yourself, okay? You can use this website to try it. So this is 2x plus 3. Okay. So this is y equals to 2x plus 3. So the question asks that whether is this a one-to-one, many-to-one, or one-to-one, one-to-many. All right. So this one, it will be 1-to-1, right? 1-to-1, right? I use your short form now, okay? O-O-O-M or M-O. All right. All right. 1-to-1. Then the next one is y equals to x squared plus 4. So this one equals to x squared plus 4. Yeah, so this is the shape of the graph. This is the shape of the graph. This one looks like this. Yeah. So this is y is x squared plus 4. And then the next one is, okay, so this one, is it one-to-one, many-to-one, or one-to-many? So this will be many-to-one, right? So m to 1, many-to-1. Because there are more than one x, they can give you the same y. Usually, if you see the square graph, it's all many-to-one. Unless later on you learn, they will restrict the value of x, then it's different. So the next one will be y equals to 2x cubed, right? That is question 3. So y is 2x cubed. How will it look like? X. Okay, so this is how it will look like. Y is 2x cubed. So this one, what do you think? Is it one-to-one, one-to-many, or many-to-one? So the graph, which means that here it will just go on up straight line lah. Then here will go down. Okay. So this one is actually 1 to 1. Okay. Okay. The next one, y equals to 3 power x. Y is 3 power x. So how will this graph look like? Y is so it will look something like this. Yeah. So the graph will look something like this. So this one is just like this, a straight line. So this one will be 1 to 1. Okay. This is okay. So this is the first four lah. So the next one, y equals to okay, so let me wait. Okay. So the next one is y equals to -1 over x. So this graph, how will it look like? So okay, so this is how it looks like. Okay, so this is how it looks like. So actually this one, if you recall this shape, right, this one doesn't touch 0. This one also does not touch 0. So therefore this will be 0, 1 to 1 lah. Because it will not touch the zero because for any fraction, the bottom cannot be zero, right? Yeah. So question number 6. Okay, 6. So y equals to x squared plus 1. So how will this look like? X squared? Yeah. So is this one right? So what do you think? Is this? So this one is actually 1 to 1. You must be wondering why. You see this one? This is many to 1, right? Question 4. Question 2. Then why this is 1 to 1? All right. It all because of this. If you look at this, this part. So R, the first 4 question is all R. So R means real number lah. Real number are so far up until this point, every number that you have learned are all real numbers. So next time when you learn complex numbers, those are not real numbers. So for now, if they put R real like this, which means that it's from negative infinity to positive infinity. So all the values of x. But here they restrict the x, right? They restrict the x. So if I restrict the x here, if I restrict the x to this region, then it is 1 to 1, right? You see not? So it's different. So question 5, even though they restrict to just the positive side, but it does not change the mapping. It's still 1 to 1 whether you restrict or not, because it does not touch 0. It never touch 0. So here, now this question has a difference, because once you restrict it, it becomes 1 to 1 for this quadratic graph. Okay. So question 7 is y equals to 2 over x. All right. So y is 2 over x. Y is 2 over x. Yeah. This is how it looks like. Y is 2 over x. So similar to this one, question 5, this one will be 1 to 1 lah. You remember that for any fraction, your bottom can never become 0. So your x can never be 0 here. All right, you can try on a calculator, you get math error if you put the bottom as 0. So question 8. Okay, question 8 is y equals to positive negative x. Okay, this one is actually the same as this example just now that I used. This one. Okay. So this will give us. So even though you restrict it, x is positive, or the positive region, this whole thing is many. 1 to many, right? Okay. If you key in this in Desmos, let me try. Yeah. So if you key in Desmos, it will just give you. It will just give you the top. That's why they have a positive negative here, because you will also include the negative inside. Okay. So yeah. So if you can, so if you see, if I add the negative, then you have this shape lah, this thing lah. That's why there's a positive negative here. Okay. Yeah. So that is all for mapping lah. All right. It's just a very short part. It's just revolving around the tree. This tree. 1 to 1, many to 1, and 1 to many. Okay. So the question. Okay. Next is okay. Okay. Definition of a function. What does it mean by that? So in order for, if you read this, right? Okay, I give you 1 minute to read it. Yes. So what it's saying here, a function is a rule that maps x value to just one y lah. Okay. So it's either 1 to 1, many to 1. Yeah. A core function. So which means that if you have 1 to 1, many to 1, these are functions. If you have 1 to many, this is not a function. Because based on the definition, a function is something that when you put the x value inside, you can only get one value of y. All right, okay, let's see. Maps each x value to just one y value. Yeah. So that's why this square root, this thing is not a function. Basically, even though many to one is also a function, because many to one, okay. Because when you substitute in a value of x, let's say x is 5. Wait, we go back to this one. Yeah, we go back to this. Okay. So if I put x is 5, right? When I key in x is 5, I only get one y. I don't get multiple y. So even though two different x's give you the same y, it's okay because for one particular x, you only get one y. This one, you put one x, you get two y, so it's not a function. Basically, your ending must be 1 to make it a function. So this is what it's trying to say lah, where this is a one-to-one function. Okay, so if you look at the exercise, okay, exercise 1, which of the mappings in exercise 1.1 are functions? So as long as it ends with a O, it's a function. So let's look back at the ones that we've done. This one. So this one, you only get this one, right? So it's a function lah. So this one is also 1, so it's a function. So this is also function, 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 because one x can only give you one particular y. This is a function, and this is not a function. So all the 1 to 7 are all functions, except 8 is not a function. Okay, so this definition will be important later on lah. Yeah. Okay, so all right, we can. Question 2 says that you want to find the range for each of these function. Okay, now we will, before that I need to teach you what is range, okay? A set of input values for function is called domain. A set of output is called range. So the keyword is input, domain, output, range. So basically your x is your domain and your y is your range. So your range of x is the domain lah. Your range of y is called the range. This is a mathematical term. So in this case, okay, let's look at this. 2 is okay, between -2 and 8. So this is a straight line, right? So if we look at okay, so this is a straight line with this, and this is -9, right? So this is the graph lah, right? So this is y equals to x minus 9, right? So this will also be, this one is also 9. But now they restrict the range, the domain, in such a way that it's from -2 to 8. So when it is -2, when it's -2, what is this y? What is this y? -2, this is -11, right? So the -2, when x is -2, fx, your y is -11. So when your x is 8, when x is 8, this point will be, what is this point? This is -1, right? So this one, you will see that from this point to this point, okay, this point and this point. So this thing is your range. This thing is a range, okay? And this one, this part, and this part is your domain. All right? If you look back, when we say y equals to x minus 9, your input is your x, right? So this is your x is your, this one, okay, your x is your input. Your y is your output, right? So that's why it's like this. So this is the range and this is the domain. So for question A, your answer will be fx between uh, -11 to -1. So that's all. That's all they are asking for. That's all they are asking for. Okay. Okay, now you can try to try a few more. All right. So maybe B, C, and D. You can use the Desmos to help you figure out, yeah, to help you figure out the shape of the graph. Okay, so question. Okay, so question B, if you see this graph, this is B. This is B. Y equals to 2x minus 2. Okay. So from 0 to 6, right? They restrict it from 0 to 6. So your x will be restricted from here to here, right? So this is your x value. So when your x is 0, your y is -2, right? And when your x is 6, your y is 10, right? This is 10. So which means that your range is fx is between -2 and +10. Okay. All right. Yeah. So you can use the graph to help you see lah. Okay. So for question C is okay. Let me draw the graph. 7 minus 2x. Okay. So 7 minus 2x. Okay, so 7, I know, 7 minus 2x, negative 3. This is negative 3 and positive 5. So you are in this. So you notice that this one, eh, wait ah. I don't have the value. Let me, negative. Okay, this one. All right, so it's between negative 3 and positive 5. So negative 3, this point is 13. And then 5, this point will be negative 3, right? Okay, so fx is between negative 3 and 13. Okay, so this is C. Okay, D, this is D, sorry. Okay, so this is 7 minus 2x. So the other one, fx equals to 2x squared. Okay, so the shape of the graph will be, okay, so this is the shape of the graph, 2x squared, okay? From negative 4 to positive 3. So this is negative 4. Again, wait. 3 got right. Okay, wait. Okay, anyway, the graph is too. Okay. So when it's negative 4, this will be 30, right? This one, 30, right? Negative. It's actually 30. Okay, like 30. It's not a nice number. It's actually 32, okay? 32. Okay. And for positive 3, this will be, this is 19. This is 19. Yeah. 2, 18, sorry. 18. Okay, so now is fx between 18 and 32, right? It's no, right? This is not right. Because fx is actually between 0 and 32. Why? Because 0 is the smallest value here. So just because you see the graph, right? Go down and go up again, right? So you need to choose the lowest point, not what is x, what value of fx when x is negative 4. Because negative 4 will give you 32, and then 3 will give you 18. So if you put 18 to 32, then you're not correct lah. Because the graph lowers some more, right? Because when x equals 0, fx equals to 0, and x is 0 is in within the domain that they ask you to. Okay. So that's why having the shape of the graph is important lah. Okay. Because the graph, like for the first two graph, as x go up, the y go up, right? So there's no going down and up, there's no changes. Whereas this one, there is a change. So that's why it's different. Okay. You can try E and F. So this is the E. This is fx is 3 power of x. And this one, the other one is -1 over x. Okay. So if you, this is fx equals to -1 over x. So you look at your domain, your lowest point, this is -4, right? So, all right, from the graph, it's between here, it's basically between here and here lah. Between here and here in this range. So you notice that if you look at the graph, it is going up, right? There's no like, go up and go down like just now. So here you substitute when x equals to -4, your fx equals to minus, 1 over 81. And when x equals to 3, fx equals to 27, right? And so we can say that your fx is in a range of, 1 over 81 to 27. Okay, yeah, okay. Then this one is between 1 and 6. So 1 is here and 6 is here, right? So it's between here. So when x equals to 1, fx equals to -1, right? So when x equals to 6, fx equals to -1 over 6. Of course, you can't see it from here lah. All right. So which means that your fx is between -1 and -1 over 6. Negative. Yeah. Okay. Okay, someone has a question on whether do we substitute the smallest value as the lowest range and the biggest value as the highest range. Okay. So what this person means is that, you see, here the range is -4 to 3, right? So I substitute x is -4, fx is 1 over 81. I substitute x is 3, fx is 27. So my range is between 1 over 81 and 27, right? Okay, this works for this question, but you cannot do this all the time. This question, it still works because you see this one, the lowest point is when x is 1 in this range, and then when x is 6, it goes up higher, right? There's no turn, right? So that's why this one works for this. Oh, Uh, 3 power x, when x equals to -4, your fx equals to 3 power -4. So this is actually 1 over 3 power of 4, which is 1 over 81. You can use a calculator to get it. Yeah, as I was saying, for this one, it works. When you put x is 1, that's the lowest range, and x is 6, that's the highest range for in this 1 to 6. So this will work for this question, but it doesn't work on every question. That's why it's important to know the shape of the graph so that you can see where it turns. Like this question just now. This one, okay. This one, let me repeat this. So this one, x is between, your x is between what? This is 2, -4, and 3, right? So if you put x equals -4, your fx equals to 16 times 2 is 32. Okay? Fx is 32. This one is fx equals to 2x squared. Okay, let me write this equals to 2 -4 square equals to 32. So when x equals to 3, fx equals to 2, 3 square equals to 2 times 9 equals to 18. All right, so the lowest x, the smallest x is -4, which gives us fx 32. The biggest x is 3, which gives us fx is 18. But your range is not 18 and 32. It's 0 to 32. So you need to look at the graph to see where is the lowest point. You cannot base on the smallest x and the highest x like this. It doesn't work on all the question. So you need to be careful. All right. For these two, yes, and these two also, yes. So you need to check. Okay. Okay, not. Okay, give you 1 more minute, then we can move on to the next part. Okay, the next question is question 3. We, yeah, you try and see. So this one, x is bigger or equals to 0. They already said this is your domain. So just get the shape of the graph, then you can tell. So this one, this graph, this graph will look like this. Yeah, so this graph will look like this. So if you are looking for, they said that x is bigger than 0. So we start from here onwards, right? Start from here onwards. Okay. Start from this point onwards. So now if you look at this, what will the range of G be? So for this question, your G is bigger or equals to -5, right? Because you fix x, the smallest value of x is 0, so it starts from here. And so happen that this is the lowest point. So that's why your G is bigger than 5. So there's no ending of x. They just say that x is bigger than 0. It doesn't stop. So your function also doesn't stop lah. Just like this lah, because it keeps going up until infinity. Okay. You can try question 4 and 5 first. I think I will. Okay. So this is question 4. This is question 5. Yeah. So question 4, 4 minus x squared. So 4 minus x squared. Okay. So this is 4 minus x squared. And they say that your range is all real numbers. The domain is real numbers. So you basically there are no restriction lah. Every value of x. So in this case, what is this point? This point is a 4, right? This point. So we can say that fx is smaller or equals to 4. Because it doesn't go higher than this one. And this one, it will just keep go down indefinitely. There's no ending. The next part, the next question they have x is bigger or equals to 1. So that one, you need to 3 minus yeah, so this one will be like this. So they restrict x to be bigger than 1. So which means that bigger equals to 1. So it's here onwards, lah, right? This point onwards forward. So you start, what is the highest point here? Highest point is 3, right? So your range will be fx is smaller or equals to 3. Okay. You can try the other 3 questions, 6, 7, and 8. So in Desmos, you can tap here. There's a point here. You can tap and it will tell you what is this point when you're using this. When you see a dot like this, you can tap it. Okay, so this one, 4x plus 1 square minus 2. So you will get, this is the shape of the graph. And why they put the negative 1 over 4? Because it's here lah. Okay. Yeah, so here they only tell you, they only say that the x is bigger or equals to negative 4. So it's from here onwards lah, this point onwards lah. So which means that your fx is bigger or equals to negative 2. Right? Because your y, the vertical, the lowest point is negative 2. So fx is like this. Yeah. Then how about the other one? This one between 2 and 7. That's okay, 8. Okay, this one. Yeah. Okay, so this graph, okay, this is something different. Yeah. So we can tell, you can see that the highest point is 3, 8, which means the highest point is 8 lah. Fx is 8. But they want 2 and 7. So 2 is here and 7 is here. Okay. 2, 3, 4, 5, 6. 7 is here. So this point you can calculate it lah. So which means when x equals to 2, your fx equals, yeah, so this will give us what is, you get 7, right? So when x equals to, when x is 7, 8 minus 7 minus 3. Yeah. So it's negative 8. So can we say that the range fx is between negative 8 and 7? This is not right. Because your starting point, your highest point is 8, right? So, and this 8 is in between this range. So, which means that your fx is actually between -8 and 8. Yeah. So that's why the shape of the graph is important to see. And you must make sure that the maximum point, the highest point, is in within the range here. If if instead of 2 to 7, they give you maybe 4 to 7, then it's different. Then you cannot include this 8 anymore. So okay, the next one. So the next graph will just be this. So this is 1. This is 1. This is 1, right? So this one will be 3. Yeah. Okay. This graph, wait, think you cannot become negative. So this one, wait, can. Okay, so this one, it will keep go down lah. Okay, it will keep going down. So this one, your fx is just smaller or equals to 3 because your highest point is 3. And if you look at the graph, it actually goes down some more. Yeah, so there's no ending to it. It will just keep going down all the way. Yeah, because they already fixed x is 1 onwards, right? So yeah, so that is for question 8. Yeah. Okay. We take a 5 minutes break, then we continue again. Okay. Okay, let's continue with the next part, which is question 9. So question 9 is a bit different than the ones before this. So why is it different? Okay. So question 9, there is a typo in the question. It's actually not largest possible domain lah. It's just find the domain. Basically, you want to say what is the value of x in such a way that this function can happen. So for question A, so fx equals to 1 over x plus 3. So for this question, your answer, your x is, this is r. This is actually, it means an element of r lah. Basically, x can take any value of r, but x cannot be -3. That's the only restriction. So you can take any real numbers, but it can be negative 3. Why? Because any fraction, your bottom cannot be 0. Yeah. You can try the others. You can try B, C, and D first. Just try. If it's wrong, it's okay. Yeah, basically, if you see fractions like this, you just want to choose a value of x in such a way that the bottom gives you 0, and you restrict that. You just disable that. Then this is to say that I want every value of real number lah, from negative infinity to positive infinity. So in this case, your x is still an element of R, all the real numbers, but your x cannot be 2. So the next part, yeah, you can take all the real numbers, just that there are some restriction lah. Then you need to set that restriction. So here, x can also be all the real numbers. Then we set the restriction. X cannot be 3, and x cannot be negative 2. Because these two will make the bottom 0. So we don't want that. So D, fx equals to 1 over x squared minus 4. So to make it easier to see, you can factorize this lah. I hope you still remember how to factorize. So this is x plus, let me write, x squared minus 2 squared, right? Then this is 1 over x plus 2, x minus 2. You just remember any a square minus b square is always equals to a plus b, a minus b. So I'm using this to do this. So what is the domain of x? X is still all real numbers, but x cannot be negative 2, x cannot be 2. Yeah. Okay, for E, you, okay, let me, before we go to E. So for any y equals to a over b, your b cannot be 0, right? So we use this fact for us to solve this one. Then when it comes to y equals to square root of x, this one, your x must always be bigger or equals to 0. Because root, you cannot have a negative, right? Yeah, when you learn complex numbers, you cannot, but that's not in your syllabus. So for now, you just accept that you cannot square root a negative number. So everything inside the root is bigger or equals to 0, because x can also be 0. So 0 is an acceptable value. So for question E, fx is x cubed minus 4 square root. So based on this, I want x cubed minus 4 is bigger or equals to 0, right? So x cubed is bigger or equals to 4, and x is bigger or equals to cube root 4. So x is all real numbers. Sorry. No. Nah, just this. This is the final answer. Wait, let me check something. Why not you? You write the real number lah, okay? Write the real number. So x, write the real number, and x is bigger or equals to cube root 4. Yeah. You try for the others, F, G, H, and I lah. Yeah. So fx equals to x plus 5 square root. So you have a square root, you want the square root to be positive. So x plus 5 must be bigger or equals to 0. So x is bigger or equals to -5. Then x is an element of real number, and x is bigger or equals to -5. Yeah. Okay. So question G, gx is 1 over x minus 2 square root. Yeah, so now they combine the two things that we talked about just now, the fraction and the root. So you have to combine these two lah. Yeah, because now the root is at the bottom of the fraction. So which means that your x minus 2 is bigger or equals to 0, and your x minus 2 cannot be 0. So therefore, x minus 2 is bigger than 0 only. You don't include the equals because we have these two, right? You need to satisfy these two conditions. X plus 2 is bigger than 0 because of the root, bigger or equals to 0, and then x minus 2 cannot be 0 because of the fraction. So x minus 2, so your x is bigger than 2 lah. Just like that without the equal. So x is an element of real number whereby x is bigger than 2. So when you have to look at both the fraction and the root. Try H. So this one, your 3 minus 3x is bigger than 0 lah, without the equals because it's at the bottom. All right, so this will be 3 is bigger than 3x. So 3x is smaller than 3, and x is smaller than 1. So x, an element of real number, and x is smaller than 1. So this x at the top, there are no restrictions for it. So you don't have to bother it. So you just look at the bottom. Because the top doesn't affect anything. So whatever the bottom value can accept, the top can accept. So I fx equals to 1 minus x squared. Then how? What are the restrictions for this? So this one, your x is just r. There are no other restrictions. So no other restriction. Okay. Yeah, so it's based on question 9, just this lah. The bottom of a fraction cannot be 0 and root must be bigger than 0 or positive. Yeah, I give you 1 more minute, then we enter the next part. Composite function. Okay. So far we have used you have seen us using fx gx, right? So this is another way of writing a equation. So for example, right, if you take y equals to maybe 4x plus 7. So if we want to say when x equals to 1, let's say your y will equals to 1 plus 7 equals to 11. All right. So when we have y and x, this is how we write it. But when it comes to function, if I write fx equals to 4x plus 7, I can straight away write f1 equals to 4, 1. Right? You don't have to write when x equals like that. So this is, when you write f1, it means that your x equals to 1. So it's a simpler way to write it lah. So you can just substitute this value. So which means if I have f10, then this will be 4, 10, 47. Just like that. So this, whatever that's inside the bracket, you substitute into all the x's. Okay, let's say gx equals to x squared plus 2x minus 3. So g1 would mean that every x value will be 1. So it will be, yeah, and this is 0. Okay. So if I want, you can also write a negative number inside, like negative 2. So negative 2 will be negative 2 square plus 2 negative 2 minus 3. So 4 minus 4 minus 3 equals to negative 3. Yeah, you can put fraction or anything. But if I want to change the letter, let's say I put G, let's say I put G and I put a Y inside. So what would this become? So this will give us y squared plus 2x plus 2y minus 3 lah. So your x becomes all your y. You just substitute your x to become y. Yeah, you can choose any lah. If you put h, maybe p, constant p, then it will be p squared plus 2p minus 3. Okay, so why do I do this? Because now we will enter the composite part. Okay, so fx equals to 4x plus 7. Then maybe hx equals to 2x minus 1. So what if I write fhx? Then what do we need to do? So you see that when we have this bracket, right? Everything that you put in the bracket, you just substitute that thing as the x, like this. So if you have fhx, it means f bracket hx. So this actually means 4 hx plus 7, because your this whole x becomes your hx. So this is what we call composite function, because you are putting a function inside a function. Yeah, like inception. All right, so this one will give us how? So to to help you understand better, so you can put 2x minus 1, because hx is 2x minus 1, right? So it's 4 2x minus 1 plus 7. Then you simplify it lah. 8x minus 4 plus 7, 8x plus 3. So this is the composite function of this. So what if, okay, how about you try for this question, what is h fx? Just try. What will it become? So hfx, the same question, okay? So it means that fx is 4x plus 7, right? So this is h 4x plus 7. You substitute 4x plus 7 into your h. So this will become 2 4x plus 7 minus 1. So 8x plus 14 minus 1 is 18, 8x plus 13. Okay, yeah. Okay, let's try one more example. Now let's have okay, for example, let's say G, you know, okay, Gx equals to 2x squared minus 2, and Hx equals to 4 minus 3x. So you try to find, okay, GHX, GHX, and HGX. See, what do you get? So GHX means you put H into G lah. So GHX, 4 minus 3x. So all the x's for the G will become 4 minus 3x. So 2, 4 minus 3x square minus 2. So this one, you can so this is 2, 16 minus 2. So it's 32 minus 24x minus 24x plus 18x squared minus 2 minus 48x plus 30. Yeah, so when you expand it, you will get this. This is the final form of GHX. Then HGX, so this will be HGX. You substitute G into H now. So this will be H 4 minus 3x. Sorry. H GX is 2x squared minus 2. 2x squared minus 2. Then this will be 4 minus 3, 2x squared minus 2. And minus 6 x squared. All right, so this is HGX lah. How about this? H square x. How do you do? How do we do this? You try and see. Try to guess it. So when they write H square x, right, it's actually the same as H x lah, okay? So this will be H putting of hx into itself. So this will be h4 minus 3x equals to 4 minus 3, 4 minus 3x. So this will be 4 minus 12 plus 9x, which is 9x minus 8. So now try this h cubed. So HQX, you have triple H, right? Right, like the wrestler. So triple H. So triple H actually, since you already have H square, right? You can use this value to substitute inside. So you can put H square X. Yeah. If you want to put H into H square also can, so it's up to you. So this will be H 9x minus 8, which is 4 minus 3, 9x minus 8, plus 24, plus 28. Yeah. Yeah. Okay. So this is like this lah. Okay, what if the question asks, HG maybe 2. How do we solve this? So this one you can do this lah. Because we already know HGX is this, right? Right? So we just take equals to 10 minus 6, 2 square. So this is 10 minus 24 is negative 14. Okay, so or you can choose another way, okay? So this one you can say that this is G2 lah. Yeah. So this way, what is G2? So this is H. G2 will be 2, 2 square minus 2. So this will give us H 6, right? Yeah. So which is 4 minus 3, 6. Negative 14, which is the same answer. So of course, at this point, you can choose whichever way you want. But sometimes the question directly asks you to find HG2, which means that you will need to find HGX first before you use the first method. The first method needs you to have HGX. But if you don't have HGX, usually it's easier to find G2 first as a constant 6, then substitute the 6 inside. So it's easier this way. So you don't have to find HGX first. But both ways will give you the same answer. So you can see that some question. Okay. You can try this out, okay? 1.3, question 1. Mm. So in this question, they want GF4, right? So you can use either the first or the second method lah. The first method, you need to find GFX first. Okay, I'll show you both lah, okay? Okay, so GFX equals to GFX 2 minus x squared, which is 2 minus x squared over 2 plus 3. Okay, so this is g of x. So g f4 will equals to 2 minus 4 square over 2 plus 3, which is what is what? Negative 7 plus 3, right? Okay, so if I were to do okay, g f4. So I find what f4 is. So f4 will equals to 2 minus 4 square. So this will be minus 14, right? Then this one will give you minus 14 over 2 plus 3. Yeah. So actually, the second method is faster if you don't need to find GFX. Yeah, one step faster lah. This one you have to find. Of course, both methods you can use it, no problem. Yeah. You try question 2. So this one is f square 3, means ff3. Okay. So this one, so f square 3 equals to f3, right? So this one will give us 3 minus 1 square. It's 3 minus 2. 3 minus 2 minus 2. So this would be 1 1 square minus 2 is minus 1 lah, right? So you get minus 1 minus 2 square minus 2 equals to 7. Right? Negative 3 square is 9 minus 2 is 7 lah. Of course, you want to find ffx first also can. You will get the same answer. Right? Okay. We try question 4. Yeah, in case you don't know, at the back of the notes that you get, there are answers. So you can attempt them yourself lah, and then check if it's right or wrong. Okay. Usually I won't discuss all the questions, just that 1 by 1, 1 by 2 wasn't that long, so I just discuss everything lah. All right, so this one, okay. F is given by that. The function g is this, find fg6. So fg6. So this one, yeah. You see this question, if you do fgx first, it becomes very complicated. Okay, let's see. So fgx will be yeah. So this will be 3x plus 4 over x plus 2 minus 2 square plus 3. See, it becomes very complicated, right? So, okay, if I put f g6, then you will get, just substitute here lah. This will 22 over 12. 22 over 8. Uh, 57 over 16. Yeah, so 57 over 16 lah. Yeah. So you can choose like either method 1 or 2. No issue. Okay. Next, you try question 6. So fx is 2x minus 1. Gx is 8 over 4 minus x. Solve equation, gfx equals to 5. So this is a bit different. This one, you basically need to find what is gfx. And then you equate it to 5 and solve for x. Okay. So this one, you have no choice. You have to find the gfx. So this one equals to 8 over 4 minus 2x minus 1. 8 over 3, 5 minus 2x. Okay. Then gfx equals to 5, right? So therefore, 8 over 5 minus 2x equals to 5. So 10x is 25 minus 8. X 17 over 10, right? Yeah, 17 over 10 lah. Yeah, so this is a different type, slightly different type. Question 6. Okay, you try another similar one. Question 7. After you're done with 7, you can try 9. So this one, x equals to 5 square root 2. And this x is 1 over 3. 1 plus 2. Yeah, this is from the answer behind lah. Okay. So fgx is 4. Need to find fgx first. Okay. So this will be 50 over x plus 3. So fgx equals to 4. Yeah. So 50. Okay. Oh yeah, there's a square bottom. 50 over x square. So, okay, 50 over x square equals to 1. Yeah. So x equals to, if you take cert 50, you have a plus minus, right? So it's negative cert 50 and positive cert 50. But because it says your x must be bigger than 0, right? So your x, so this one you reject lah. So therefore, x is only square root of 50. Square root of 50 is the same as 5 square root 2 lah. How they obtain it is you take 50 as 25 times 2 square root. Then this will be square root 25 times square root 2, which is 5 square root 2. Yeah. If you have the white calculator, it will straight away give you this. If not, this is how you actually obtain it. Why am I? Okay. So question 9. Okay, question 9. So you want to find GHX equals negative 3. So GHX is negative 3. 1 minus 2, 3x minus 1 equals negative 3. All right, there's a square right here. Right, so this one, you get this. So 1 minus 18x squared plus 12x minus 2 is negative 3. So, okay. This will give us 18x squared minus 12x minus 2. So 9x squared. So this one, you cannot factorize, so you have to use the quadratic formula lah. Minus b plus minus b squared minus 4ac over 2a. So which means that, so a equals to 9, b equals to negative 6, c equals to negative 1. So this will be negative of negative 6 plus minus negative 6 square minus 4, 9, negative 1. Okay. So, okay, 6 plus minus. So this is square root of 72 over 18. So this one you can, square root of 72 is actually, square root of 72 is square root of this, which is square root 36 times square root. So this will be 6 square root of 2. 6 plus minus 6 square root of 2 over 18. Then you can factorize the 6 out, right? So 1 plus minus square root 2 over 18. So this will be 1 over 3, 1 plus minus square root of 2. So we want to check whether the minus can be accepted or not. It says here that your x is always bigger than 0, right? So which means that you have to reject one value lah. So x equals to 1 minus square root 2 1/3, 1 plus square root 2. So this one you will have to reject because x is negative here. So therefore, your x equals to 1/3, 1 plus square root of 2, which is the answer here. Okay. Okay, if you're already done with this, you can try question 10 first. It's something different, just try. So basically for question 10, I do the first question so that you know what it is actually asking. So the first question, your answer is f g x, right? Because you put g into f and you will get this one, right? Now you try B, C, and D. So it's given that f is x squared, g is x plus 2. So gx, how do you want to get x plus 2 square? You substitute g into f, right? Because you see this, right? This is f x plus 2. So if you substitute x plus 2 into fx, you will get this one, x plus 2 square. Yeah. So how about b? So b will be gfx, right? Because if you put the fx into the g, then it will become the x will become square, right? So this is g x squared, which gives us what the question. How about c? So c, how you want to get x plus 4 here? This will be g x, right? Because you put g into itself lah, so it becomes, so this will become x plus 2 plus 2 is x plus 4. That's how we get x plus 4. So this is like reverse lah. They give you the final form, ask you to guess which one is it. Then how about the last one? Last one, I think you look at the first three questions, you already know what's the last one already, right? There's one more left only, one more possibility left only. So f(x) So this will be f x squared. Then x square, right, is x4. That's how you get Okay. Yeah, so that is all for today's class. And since your first class, I hope I didn't scare you or what, like, I hope you're able to follow so far. Anything you can, text me in the chat. If you have any question, you can text the admin and they will send me a message. Yeah. So that's all for today lah. Thanks everyone. And thanks for switching on your camera and showing your face. Hmm. So guys, if you are already done, no homework, yeah. Someone asking. Yeah, if you're already done, I need you to leave because I have another class with teacher May at 7:30. All right. Don't worry about copying. I will send everything that I wrote here to you. You don't need to copy. All right. Sorry, I didn't say earlier. Usually I will send together everything I wrote together with the video lah, recorded video.